impeding alpha particle. So from this experiment, Rutherford and this group, they were confirmed that, okay, this alpha particle is also positively charged, and there should be some positively charged particle is here, which is repelling or not allowing this alpha particle that is positively charged to go back, only few of it, only 0.1% of it. So that means this alpha particles at this gold foil is very, very small. All of them passes through. That means it is mostly empty space. The atoms are mostly empty space. So now we know that atoms are mostly empty space, right? It has 90% of atom is a empty space, right? So from here, this Rutherford planetary model came out, and afterwards, Niels Bohr came out with this planetary model that nucleus is at the center, and then it is moving around it, all around it, just like the planets do. So this is called the Bohr's planetary model. But this Rutherford, of course, Thomson, he gave the first idea of how the atom would look like, and the Rutherford one is the most complete one, okay, the most helpful one to understand what is an atom look like. So this is called the gold foil, Rutherford gold foil experiment for finding out this structure of an atom. Okay, so this is the thing that I was supposed to say, and then okay, we will go to the tutorial now. But before the tutorial, if you have any question now, you can ask. I can see the chat box now. All right. I can see the chat box now. If you have any question, anyone. Okay, no question, yeah? Good. So what I'll do is I'll give you 5 minutes, not 5 minutes, 3 minutes. After that, we start our tutorial. Okay, so I'll see you after 3 minutes. Hello. I hope you are here. So, the section 1 for concept invention. Oh, before we go here, how many of us are here? How many of us are here? There are 22. Good. So that who is not here, let me call them. Muhammad Ali, are you here? Muhammad Ali. Muhammad Ali, you are not here. You just log in. Muhammad Taha. Muhammad Taha, are you here? Oh, you guys are not here. Just you log in and then go away, yeah? Okay. Jolene? Jolene, are you here? What's wrong? Okay, so I'll show absent everyone, okay? Juliana? Shafaf, are you here? Shafaf? Oh, you're typing. What's the problem with you guys? Just say yes, it's so difficult. Okay, so Muhammad Ali, are you here? Okay. What I wanted to announce is that we will start our lab next week. All right. So come to the lab on Monday, 2 p.m. Those who said that you want to come, please come to the lab at 2 p.m. The lab will be B708. I will announce it on Canvas as well, but it is recorded. Okay, and you, I guess everybody is here, all 22 of you. So that since it is recorded, all 22 considered you are here and you are listening, and we'll start our lab on the 22nd of March. That will be Monday at 2 p.m. as per the timetable. And also, okay, so yeah, you should bring your safety gears, like your lab coat and the goggle, and of course in the full trouser and covered shoes. Okay, so I'll see you on Monday in the lab. Okay, so now go to that tutorial. Okay, so our tutorial, it says that first question, describe the experimental basis from Rutherford's gold coil experiment for believing that the nucleus occupies a very small fraction of the volume of the atom. So that's what I was just explaining, right? So if there is a when all the alpha particles was going through it, that means it is very positive. I mean, a small amount is only occupied, which is being taken away. All right. Okay, so indicate the number of proton, neutrons, and electrons for each of the species. I don't need to, I think I don't need to do it because you are already aware of it. So here on this name here, so when we say nitrogen 7 and 15, that means there are 7 proton here, and proton is passport or identity number, so we cannot say, or we cannot fake it, or we cannot whatever, we can change the proton number. So proton is 7, so there should be 8 number of electrons to make it 15, right? This total atomic weight is 15, or atomic number is 15, so that we have to make it 7 plus 8, 15. So there are 8 neutrons are in nitrogen, and since there are 7 protons, all are positively charged, and this element is not carrying any charge. It is neutral, right? Here it is 0, so it's not carrying any. For this example, it is 2 positive charges carrying, but it is not carrying any charge, so it should have exact same number of same number of electrons should be there as is the number of protons. So 7 protons, 7 electrons. That means positive negative charges cancelled out each other. For this case, it is saying 25. It says 25 proton, and then 27 neutron, and then 26 electron. If we look at the periodic table, we will see that 25 proton is magnesium, Mg, right? It will be manganese. It will be manganese from the periodic table, and we have to write this 25 here on the lower side, okay, and 25 proton, and then the neutron is 27, so 25 plus 27 both together will be 52 on top left side, and it is carrying more electron than proton, so it will be how many? 1, right? 25 proton, 26 electron. So 26 electron means it is carrying 1 more on excess of electrons, so it will be negatively charged. 1 negative charge. For strontium, 2 positive charge, the same thing. I think, do I need to explain it? Because it is carrying 2 positive charge, that means it will be short of 2 electron to be neutral. It is 38, the number of proton, so it will have 36 of electron. So it's too short than proton. Proton is positively charged, electron is negatively charged. So since 2 proton is more, it will be positively charged, 2 positive charge here. And for this case, the number of neutron, 84 minus 38. 84 is the total number of atomic number. So 84 minus 38 will be this number of neutron, right? 46. Okay. So in this way we can find out number. The following table gives numbers of electron, proton, and neutron in the atom. Join the. So for this case, A is 555. Of course, A is neutral. And proton and electrons are same. For what fluorine has proton and electron same as well, so it is also neutral. And G, oh no, it's not fluorine, it's F only. Okay, A, B, C, D, E, F, G. So G also has electron and proton number is same, so it should be A, F, and G are the neutral species because they have number of proton and number of electrons same. Which one are negatively charged? Negatively charged means the number of electrons should be more than number of protons. So B, the electron number is more than proton, and E also the electron number is more than proton, and yeah, so these two. Positively charged means proton is more than electron. So for C, the proton is more than electron. D, proton is more than electron. So yeah, in this way we can. What are the conventional symbol for all of the species? Oh, okay, I know how to engage you, how to make you talk. Okay, forgot that I prepared Menti question. Can you please go to menti.com, everyone, because I will see how many of you are participating, although I cannot see who participating, but I can see how many of you are participating. So go to menti.com. Okay, everyone go to menti.com. Mohammad Taha, you asked, we don't have live lab session on Monday. The live lab session on Monday, when we do the lab, okay, in the lab, I will be trying to be online from my phone in the lab, from the lab, okay. So probably, wait, for the Menti, wait. Probably for maybe first 10-15 minutes, I will discuss or describe how to do the experiment. So for first 15-10 minutes, you can see me what I'm doing on the lab, in the lab. Okay. So yeah, I will be live there from there. And yeah, menti.com. Okay. Thank you, Daniel, for sharing this. Please go to this menti.com and I will share the what do you call it, code right now. Hold on. Present, and the code, oh, the code is, oh wait, another thing, sorry, I forgot to start the count timer. How do I start count? What is the timer here? Whatever. I cannot find the timer. Okay, but the code is, I'm sharing now, that 9318 and 28289 6. Yeah. Use this code for this Mentimeter. Please start doing it now. I will not give you more than 1 minute. It says that from which option below an electron is easy to remove. One is, oh, here. No, not yet. Not yet. Okay. Sodium 1s2, 2s2, 2p5, 3s2. Potassium, argon, and then 4s1. Sodium plus 1s2, 2s2, 2p5. 37, 35, 30 seconds left. Faster. 15, 14, faster, more, I want more. 10 seconds. 10 seconds. Closed voting. Okay, so it is quite wide and diverse, like 9 of them potassium, 4 of them sodium plus, 3 of you say sodium in 2p5 and 3s2. But what do you see from here is sodium. I put 1s2, 2s2, 2p5, and then 3s2. Whereas actually we should have, p should have 6 electron at best, isn't it? P orbital has 6 electron as best. Okay. So that is why we should have written here P 2p6 and 3s1, right? And for K, it is argon and 4s1, of course, because this 4s1, the electron that you can see here, is after the argon, the 4s1 is here. The s1 electron is there. But for sodium, positive charge means it already had given 1 electron, right? It had already given 1 electron, and that is why it becomes positively charged. So if it's positively charged, that means it has given 1 electron, and if it is given 1 electron, remember the ionization energy. The first one is always low, and then ionization energy starts to increase, right? Just now we are talking about. So ionization energy starts again and it increases. So that is why the sodium, it will be higher because it's already was taken 1 electron, it was taken from it, and the second one, to remove the second one, it will need more higher energy. For the first option, sodium, like 3 of us choose here, I don't know here, but thank you for whoever taken. You don't have to be correct, right? It is not an exam, it is just a quiz that we can discuss more, and we can show you that what we can do and why it would be a correct or not correct. So for sodium, 1s2, 2s2, 2p5, 3s2, some of you, can anybody tell that why it is correct or not correct? Anybody wants to volunteer?
Sir, you cannot see your screen.
Yeah, just now I saw your, I don't think we can hear. Huh? I can hear you. Just now you talk. Because you did not talk, that's why I did not hear. Yes, I was here, full screen mode. I could not see. Okay. So this is what I have to. I was talking that sodium, 3 of us chose here. 9, of course, chose the correct one. 5 of us chose this one also. But can anybody try to explain why it is wrong or correct, or why this is correct, or why this is not correct? Would anybody like to volunteer? Talk.
Sir?
Yeah.
Like for the one in blue, all the P shells are not filled. Like first it should be filled for it to go to 3s2 for the 3s subshell.
I didn't get clearly because there was a network, I think. Can you repeat once again?
Sodium.
Yeah.
The 2p subshell is not fully filled and it has gone to 3s2.
Okay. Yes. This is one option. Okay. All right. Thank you. Thank you, Anupaja. We will discuss more about it. Do you want to add anything else?
Answer for sodium plus.
Yeah.
Like first it should be filled and then removed from the last from the outer subshell. The electron should be removed from the outer subshell.
Yeah. All right. Anybody else want to chip in? Anyone else? No. Okay. So the first thing is here it was sodium, but it was given that 2 to 4, 5, 9, 11 actually, right? It is 11, and then it was supposed to be sodium negative, but my typing mistake actually. It was supposed to be sodium negative, so that it has 11 electrons. And it is, as Anupaja says, that the P was supposed to be 6, right? P was supposed to be 6, and that S3S would be 1. And sodium, since it is a metal, it will always be easy to remove the electron than taken an electron. Okay. Oh no, sorry. Sodium is always 11, isn't it? Yes, sodium is always 11. Oh my God. Sodium is always 11. I mean, the atomic number is 11. So it was supposed to be 2p6 and then 3s1, right? But since 2p6, we did not fill it up, right? We did not fill it up, and it is easier to remove the electron from the outer shell, and there is only one electron at the outer shell, just like this, right? Just like this. But for sodium, sodium plus, that is already given on one electron, already one electron is given, it is supposed to be a 2p6, and then it is the hardest to remove the electron from here because it is already attained neon configuration. Neon is noble gas, and it is so stable that it is very, very hard from taking one electron away from this part. But for potassium, this is the perfect one to remove the one electron because it wants to attain the argon configuration, whereas the 4s is far away from the nucleus, right? Because it's bigger size and it is number of n, that is principal quantum number, is more than sodium. So it is the next period element on the periodic table. It's next period element after sodium. So it should be, the size is bigger. Since the size is bigger, the sodium is easy, the electron is easy to remove from its outer shell. So those who, 9 of us, those who answer here, I think you understood it and then you took this. But those who did not, you do not feel bad, because this is why if you did not answer this, I would not talk, because I would say that, okay, everyone knows this, right? So thank you, but now you know already, right? Okay. There's another one I have, and oh, I cannot show it to you, right? All right, now you are going to the Mentimeter once again. And use the code of, hold on, 4892. Let me 892 4616. Okay, 4892 4616. Just copy this one and then try to take this quiz as well. It is fun actually. We which of the following element, right, exert most shielding energy to the inner orbital electron. Like it has many orbitals, but to the inner orbital electron, which among them will have the most shielding energy? Okay, I will start counting time, 1 minute. So you have to do it now. Your time will end up now. But your time starts now. 50 seconds. 30 seconds. Faster. Only half so far of the class. 20 seconds. Faster. 15. 4, 12. 10 seconds. Faster, faster, faster. 5 seconds. Okay, so I share this now with you, that you said arsenic, eight of us choose arsenic over cobalt and calcium. Can I write here? Cannot write, but oh, what? All right. So for this case, we see that it was the question was asking that among all these three, which of the element would exert the shielding energy, or which one of them will have the shielding energy more among them all. So if we go to the periodic table, and I see I can see that you can see the periodic table. Calcium has 20, right? The number, atomic number is 20. That means it has 20 electrons as well. Cobalt has 27, and arsenic is 33. So when it's 33 arsenic, that means it has more electron around it. It has more electron around it, and it will have the most what do you call it, shielding effect to the outer shell electrons. The inner shell electrons that will exert more shielding, or will provide more shielding to the outer shell electrons, because it has more electrons, right? So yeah, and that is why it will be it is, since it is bigger, more electron it has, it will have more shielding effect in it. So how many of you have chosen the correct one? Yeah, most of you have chosen the correct one. Okay, so now let's go back to this, our tutorial today. Okay, we were talking about the atoms and ion. The following table gives number of electron, protons, neutron in atom or ions in the following elements. And we have seen how to find out what are the charges, and how to find out positive or negative charge or not. Okay, so the D answer question is what are the conventional symbol for all of these species? How do you find it? We have to go to the periodic table and see where element in the periodic table has proton number 5, because proton is 5, should be only for that electron. It cannot be for any other electrons, right? For the protons. So for on the periodic table, for 5 protons will be for borons. So it is for boron, it is for nitrogen, and so on. It's going on. We can find, you can look at the periodic table and try to find out which one is what. Which species are isotopes to each other? Isotopes when there are same number of proton but different type of neutron. Number of neutrons are different. Same number of proton but number of neutrons are different. For here A and F, number of proton are 5, but number of neutrons are different. So they are the isotopes A and F. Due to the presence of different isotopes occurs due to the different environmental situation, different pressure, temperature, and the pH, all those things, the isotopes occurs. And because of this, due to the different isotope, the average mass of an element changes, or actually taken, not changes. The average mass on elements mass is expressed in average mass. Okay, so average mass is given in this relationship, or in this equation. It is given the summation of the relative isotopic mass times the percent of abundance. Summation means all of the isotopes that occur for that element times the percentage of each of the isotopes occur are summed up together. Okay, multiplied by this and then summed up. So for an example, and divided by percentage of abundance. Percentage of abundance is always 100%. If even sometimes the percentage of abundance like 10.3%, 20%, and then if you sum it up and it becomes 99.95, is still considered 100%. Okay, so percentage of abundance should always be 100%, all right, or 1. So AR is expressed in this way, that for magnesium, average mass for magnesium will be, how can I write? I think okay, so the three isotopes, no, sorry, but for magnesium, the average mass of magnesium will be the relative isotopic mass of each of them. There are 3 isotopes for magnesium, multiplied by the percentage of abundance. Like magnesium 24 has 23.98 times 10.03, 25 will have 24.9858 times 11.17%, and magnesium 25 times 98 times the rest. So the rest will be 10 plus 11 minus 100 is the abundance for 26, and from there we can find the average mass of them. Question A is saying, what are the why the 3 isotopes have different relative isotopic mass? Because they have different proton and neutron, right? I mean, sorry, number of proton is same, but they have different number of neutrons. That is why. If 1 AMU is 1.66 times 10 negative 24 gram, what is the average mass of 1 mole of magnesium atom? Show you're working using factor level method. Factor level method means we have to find out the what we are looking for. We are looking for 1 mole of magnesium, and 1 mole of magnesium is let me try to write 1 mole of magnesium times how do I, okay, 6.022 times 10 power 23rd atoms of magnesium in 1 mole. 6.023 times 10 power 23rd All right, moles, atoms, sorry, by 1 mole. Then, oh, it is difficult. 1 mole times. Now it says that what is the average mass, right? Average mass of magnesium atoms of 1 mole of magnesium atom. So 1 mole of magnesium we have found, and then number of atoms we have found from this factor level calculation. And now we have to find out the average mass of 1 atoms there. What is per atom we have to find out. And it is 1 atom of magnesium is 24.30 like AMU or AMU. Again, we have to put divided by 1 atom of magnesium should be written. All right, and then from here we found already that how many atoms are will be we can find it from here, and then in 1 how many AMU we found it here, and then in 1 AMU how many grams we can find as well, right? So 1 AMU is 1.66 times 10 power negative 24. 1.66 times 10 powered negative 24 gram, okay, divided by 1 AMU, right? So from here, if we do in this way, we will find that it is altogether is 24.31 gram, 24.31 gram, not GM, only gram of 1 mole of magnesium. All right. So when it says that factor, show your working in factor level method, you have to do in this way, in this factor level method. If you do in other way, you will lose marks here because it is specified your work clearly. That means you show your work clearly, means you have to show in factor level method. All right. Write the electronic configuration of this species in electron in a box diagram. So for this chlorine 1s2, first of all we have to know how many electrons are for chlorine. So we know that chlorine has 17 electrons, right, in the atom, and that is why you have to show. Yeah, here you have to show by showing the arrow, half of the arrow up, 1 arrow up, 1 arrow down, right? I cannot draw it here, but 1 arrow up, 1 arrow down. So maximum 2, here can be 2, here can be 2, here can be 2, 2, 2, 2. So 2, 4, 6, 8, 10, 12, 14, and then there will be 1, 1, 1. Okay, so there will be 17 electrons for chlorine. Is that correct? 2, 4. Oh, okay, yeah. 2, 4, 6, 8, 10. No, 13. So 14. Yeah, 17 now in this way. So we can find the electrons configuration in this way. Now it says that it has loosened 2 electrons, right? It has lost 2 electron, becomes Cl positive 2. So all these 2, 2, 2, 2 stay here. Only one electron, 2 electrons will be lost. So it's not this one electron from here, another electron from here. No, not in this way. Otherwise, because here when it is 1, it was supposed to occupy 2 electrons, but it is only occupying 1 electron, right? So that means it is, you cannot, I mean, you have to have a very strong force to take this 1 electron, but it will not give you this 1 electron because it will be empty then, right? It wants someone to be there, so it cannot be empty. What it will do if you excite them too much, it will 2 electrons from this one, and then it will become 1 and 1. So 2 electrons will go out from this 3px. We can consider 3px, this one, 3py, this one, and 3pz, this one, right? So 3px, 3py, and then this should be 3pz. So everyone was supposed to be this x, y, and z are free. This 3py, 3pz, these are suffixes. Okay, so the p in this p orbital, there can be 2, this can be 2, this can be 2 orbital, and when you take away electrons, it will be 1 here, 1 go from here, 1 go from here, and same goes when it's filled up. Okay, if you fill up, it will go 1 first, and then another one here, another one here, and then only the another one, the number 4 will come here. It's not like if first 2 it is coming here and then 2 again and 2, no. All 1, 1, 1, it will fill up and then the rest will come. So for negative 1, that means it is having 1 more electron. So it will be, there will be 2 electrons into 3pz as well. The question is saying that the species with the most unpaired electron is Cl2 plus, right? Because it has 1, 1, 1 electrons. And the diagram, diamagnetic species. Diamagnetic species is when there is no paired electron, there is no unpaired electron, so that is a diamagnetic. So Cl negative is diamagnetic because it does not have any, it does not, where Cl negative, it is diamagnetic because it does not have any unpaired, all are paired, 2, 2, 2, 2, 2, 2, all are paired electrons, so that is the diamagnetic. The isoelectric species with a noble gas, of course, Cl negative, because it is, what is that? Argon, and yeah, it will be like argon structure. The species that most likely form a compound with sodium ion is also Cl negative. So it will take 1 electron from sodium and then produce a bonding between. We'll see it tomorrow. Question number 6 is just now what we discussed, that if we go from left to right or top to bottom or bottom to top, what happens, how the changes of this property changes. Okay, using the general trend in predictable, predict and explain why atom is bigger. So which atom is the sodium or fluorine? Can anybody tell which one should be bigger, sodium or fluorine? Faster, we will finish it soon. Sodium or fluorine, which one is bigger? Mohammad Taha, sodium. Okay. Anyone else? Oh, sorry, it is not sodium, it is nitrogen. Aha. Is nitrogen or fluorine, yeah? N. It's nitrogen, yes. Thank you. Nitrogen or fluorine? Yes, nitrogen is bigger because nitrogen is sitting on the left side of fluorine, right? Fluorine on the right. So we go right, from left to right, it start to reduce. So nitrogen will be reduced. because another reason is it has less proton, atomic number, that is number of neutron and proton is less than fluorine there. Which atom is more metallic character, silicon or sulfur? Okay, more silicon or stantinium, right? Yeah, so which one will have more metallic character, silicon or stantinium? That is tin actually. Yes, N is tin. Are you answering? Tin, yes. Silicon or tin, yes, because it is tin. Tin is lower here. Here, tin is here, and silicon is there. So if as we go down a period or a group, the size starts to increase, and that is why the tin, the size is more bigger than silicon, so it is easier to take one electron away from there, right? Okay, which atom is easier to be oxidized, silicon or nitrogen? Which one is easier to be oxidized, silicon or nitrogen? Silicon or nitrogen? You know, oxidation or oil, right? OIL, oxidation is losing. Remember this, oxidation is losing of what? Losing of electron, of course. So oxidation is losing of, so silicon has a more ability to lose the electron than nitrogen, so it will be more easier to be oxidized. Yep. So how many more we have? Okay, we are almost done. I will not go to the previous question, first year question, so we can do it. Anion cation formula, the name is magnesium hydrogen carbonate. All right, magnesium hydrogen carbonate. And there is, we know that is the magnesium is there and bicarbonate or hydrogen and is there and carbonate is also there. So this is magnesium and it will have 2 positive charge, or sometimes you can just write 2 plus or plus 2, both way can, but 2 plus is given better. Carbonate, hydrogen carbonate. So there is a hydrogen there and carbonate all together. First of all, there will be HOC3 and then -1. Carbonate is actually -2, but since hydrogen is attached there, so it reduces to -1, and that is why magnesium hydrogen carbonate will be MgHCO3 and all together there will be 2, because there is 2 positively charged. So to neutralize this 2 positive charge, it has only 1 negative charge. So to neutralize 2 positive charge, 2 of them will be required of bicarbonate. So there will be 2. The next one is SrCl, and from the periodic table we see that it is strontium. It is a metal, strontium, and chlorine produces chloride, right? Sn, and here we see is Cl. So there are 2 Cl, right? 2 Cl atom that we understand. There is 2 Cl atom. It makes, it tells us that, of course, chlorine is -1, right? So it should be +2. It should be 2 positive, actually, 2 positive charge. Oh, yeah. Okay. It will be 2 positive charge, strontium chloride. Iron and NO2 here. So iron 3 and NO2 1 negative. This negative charge should be on. Oh, should be here. Okay, so iron and NO3 are there, so that means it 3 of the nitrite in fact, NO2 and then this 3, because there are 3 positive charge for iron and there is only 1 negative charge for nitrite. So nitrite, there will be 3 nitrite will be required to neutralize these 3 positive charge. So that is means there are 3 nitrite in there. So it is iron 3 nitrite. All right, iron 3 nitrite. And this way the next one will be manganese 2 chloride, that means manganese 2 positively charged, chlorine 1 negatively charged, so MnCl2, and this way. I will upload this answer soon so that you can see it here. And our time is up, unfortunately, today. So any questions so far? Otherwise, I will stop here. If you have any question about this, of course, we can discuss later on. Mohammad Taha, the quiz will be available from tomorrow afternoon till Friday. Every time the quiz, there will be 3 days given for the quiz to be completed. All MCQ. Yeah, no, the thing is the quiz will be available from tomorrow afternoon till Friday afternoon. You can take any time within this time. From tomorrow afternoon to Friday afternoon, you can take any time the quiz. Only the thing is, once you start to take the quiz, you have to finish this one. You cannot just halfway do and then later you do on Friday. No. Once you start, you have to finish this. Yes. Okay, so there will be 10 minutes. And the maximum you can take twice, 2 times. You can do. If you don't like the answer to get taken, then you can, I mean the score, then of course you can take once again, but that's it. More than we cannot take more than, you cannot take more than two you have only 2 chances to take. Yes, the higher score will be recorded. So you are already familiar with this, yeah? Good. Okay, good. Okay, so do you have any other question? Yes, there will be calculation based question as well. Like mole, molarity, all those things that we have learned. Okay, so I'll see you tomorrow morning again. Okay, so take care. Have a nice evening. Okay, bye-bye.